So when we talk about the topic of inequalities, most students have seen these symbols for a while, but let's just start with some simple questions. So if I said to you, -3 is less than 7, is that true or false? What do we think? True or false? Okay. So yeah, it's true. If we think of the number line, we can think -3 is to the left, and that's fine. Okay. What about, we're going to agree that it's true. What if I said to you, -3 is less than -7? Is that true or false? What do we think about that? So it's false. You're quite correct. It's false. And the reason it's false is that if you look at the number line, -3 is higher up than -7. And so the crocodile mouth shouldn't be facing, or the big open jaws shouldn't be facing -7, because that's not greater. The greater than would be the other direction. Okay, so this is something that students sometimes find a bit confusing. So I thought, let me go over it. What about if I said to you, is -7, what about that statement? Is -7 less than -7? True or false? Okay, so this is false because -7 cannot be less than -7. Okay. All good so far. What about this? Is -7 less than or equal to -7? True or false? Things are getting a little bit more interesting here. So we have to be careful here. So what this means is that it can be either of the two. Is -7 less than -7? No. Or is -7 equal to -7? Yes, it is. So this one would actually be true. Because of that less than or equal to thing, it's possible that -7 is equal to -7. Okay, so that's something that you need to keep an eye out, because it can catch you out here. What about, is -8 less than or equal to -6? Is that true or false? Okay, so think about it. Is it less than or equal to? So it can be either one. It can be, is it less, is -8 less than -6? Yes, it is less than -6. So it's going to be true. It's not going to be equal to -6, but that's fine. It doesn't have to be both. It just has to be this or this. It's either less than or it's equal to. So this would be true. Let's do one more like this. What about -9? Is this going to be true or false? So it turns out -9 is to the left of -8 on the number line. So this part is definitely not true. And -9 is not equal to -8. So both of these are false. So it's false. So take a moment to think about those. Give me a thumbs up if you understand these little questions I've been doing now, so give me a thumbs up, give me a thumbs down if you feel a bit confused by these ones that I've been doing here. This is what I would call understanding kind of the foundations of inequalities. And so it's important because they behave a little bit weirdly sometimes. Yeah, but I always come back to the number line. That helps me. Okay, then I want to talk about some of the notation that we use, some of the language that we use when we talk about inequalities. So one of the things is the greater than. And if you see a greater than symbol, just a greater than, we say that that is open. And when we draw it on the number line, we draw it with an open circle and then a line pointing upwards, but it's greater than. So an example would be like an inequality. If I said to you, x is greater than 3, that's an inequality. On the number line, I would have a 3, and then below the 3 or above the 3 or on the number line, I would have an open circle, and then I would say all the numbers that are greater than 3 are the solution to this inequality. So that would be an open circle for that. If we have a greater than or equal to, we would say then that it's a closed dot. And in this situation, the closed dot is there, but it's still going to be greater than or equal to that statement. Now, if I then look at less than, do you know what the symbol looks like? If it's strictly less than, it's going to be an open dot, and then because it's less than, it's pointing downwards. And then for less than or equal to, it would be a closed, so it would include the endpoint, and then we just go down like this. So Cassis said, I was taught wherever the sign points to it's the way the line goes. That does make sense. Yes. Yeah, that does make sense. Okay. Let us then look at interpreting. I'm going to leave those things up on the board. But let's interpret these number lines into inequality notation. So in terms of describing inequalities, there's always this interplay between a number line and inequality notation. And there's actually two ways to describe inequalities. You could use them using inequality notation, or you can describe them using interval notation. So let me do the first two for you, and then you are going to do number 3, 4, 5, and 6 as a translation exercise. So for number 1, I see that there's an open dot, which means it doesn't include 2, and it goes up forever. Using inequalities, we would say this is greater than 2. So x is greater than 2. So it could be 2.5, 2.5, 3, 10, a million. Those are all answers to this inequality that will make the statement true. Using interval notation, we would have a curved bracket, a 2, an infinity symbol because it's going off forever, and then a closed thing like that. For the second one, the only difference is that there's a solid dot now, but it still goes off to positive infinity. So this would just be x is greater than or equal to 2. And using interval notation, there's a square bracket now, and it's all the values from 2, but including 2 up to infinity, positive infinity, and infinity can never have a square bracket. Most of the time, well, actually, all teachers are different. Both of these notations are fine. I probably will use this one a little bit more, but both are fine. So what I would like you to do now is I would like you to write down what you think the answer is for number 3 in both these ways and for number 4. And once you've done it, if you could pop it in the chat, In fact, you can do all of these, 3, 4, 5, and 6. And you can either pop your hand up to let me know if you feel like you have the answer, or you can write it in the chat. But first of all, let me give you 2 minutes to do it. Patejo, what's the difference between the square bracket and the normal one? The square bracket indicates that you include the endpoint. So if you look at the example over here, number 2, it has a colored in dot, and so it has a square bracket. Whereas when it was an empty dot, it's not including 2, it has a circular bracket. And that's the notation that we use. Okay, I'm going to get some water while you work on that. I need a top up. So for this one, we're going to have x is greater than or equal to 2 and less than or equal to 6. And over here, we're going to have 2 from 2, including 2, up to 6. Now, what I want to make sure you see is that because the dots are colored in, I have the extra little bit here. Ooh, I'm breaking my chair here. That's not good news for anyone. So, Hosi, you do have to put square brackets because you include the endpoints. Now, in reality, in a test or something, you wouldn't have to do both of these. I'm making you do both for today because I just want to make sure you understand them. But you wouldn't have to in a test do both. You do one or the other. So for number 4, it would be like this and like that. Notice how number 4 has an empty dot, which means it doesn't include the endpoints. And so it'll be all the values between 2 and 6. Okay. So please explain where the sign points with the inequality. Okay, Cass, could you be a little bit more specific? I don't know if you want to ask an audio question if you can, but so if I look at number 4, the 4 is between 2 and 6, right? And so because it's between 2 and 6, but it doesn't include 2 and it doesn't include 6, that's why I've got these, there's no little extra equals. Where if you look at number 3, it had the colored in dots. So if you look at all of these, in number 3, I've got a less than or equal to, and so it's possible to include the value 2. Let me do number 5 and 6 just to help you guys here too. So 5, you've got a solid dot. So I'm going to have a less than or equal to here. But this is an empty dot here, and so I have a less than 6. Aha. Okay, so why isn't, so x greater than 2? Oh, okay. Because x isn't greater than 6. So if you look at number 4, which you're talking about, Kaz, you'll see that x isn't going to be 7. It can't leave the farm or leave the fence, right? The fence is here. X has to be between 2 and 6. If you said x, if you had something like this, right, where this was going like that, you're saying that the x is bigger than 6. which it's not. X is less than 6 as per the drawing. Yeah, perfect. I'm glad I could help. So if you look at this part, it should be 2, and this should be 6. Now notice how there's a square bracket on the side because of the colored in dot and a circular one here. And then over here, I should have 2x less than or equal to 6. And now it's not a square bracket. I'm making a silly mistake there. But it's going to be a circular there, and it's going to be a square there. Okay, so this is what we call reading off inequalities from a number line, and you can do it using interval or inequality. Now, if you had, at the moment, you're only seeing one like number line or one interval on each number line. If you had a situation where there were 2 intervals, so let me just show you an example of that. If I had the interval from 2 to 6, and I also had the interval from 8 to 9, so I colored in my dots, then I would have to write them separately. So I'm just making one up now. Just to give you an example, what if you have 2 intervals on the same number line? If I had this, then I would write the stuff that was the same before, I would have it like this. And I would also then write an extra bit for, because I've made them colored in dots, I could also have that. So it's possible to have 2 intervals on the same number line, but we're not doing that quite yet. So there, in these examples, there is a greater than part and there's a less than part. So the x, if you think about what you're trying to describe in number 6, okay, I'll take my extra example away now. X lives in the land between 2 and 6, but X cannot ever be 2, but X could be 6. So X is greater than 2, which is sitting down here, but it's less than 6. It can't get over the fence, but it could get to 6. That's why that is there. Does that help a little bit, Tebogo and Veda? You see what I'm saying? So it's actually 2 bits that are knitted together because it's one interval. It's like a pen, and each side, the one side of the fence and the other side of the fence. Is the X always in the middle? Yes, because X is the variable we're trying to describe. Yeah, pleasure. I'm glad I could help. Okay, now let's do some multiple choice. I want you to tell me, show X is greater than -1 on another line. I want you to tell me which of these 4 options you think is correct. I just want to quickly fix my chair, which is about to fall over. I think this chair is unhappy. Oh. So X is greater than -1. So it can't be these 2 because it's got to be going in that direction. It doesn't include, so it can't be this. The answer must be B, because that's the only one that has it going in the right direction, and it's also got an empty dot. Let's do this one. What do you think the answer for this one is? So it must be less than, because it's pointing to the left, but it includes 2. So the solid dot includes 2. So the correct answer should be D. Think of it this way. Here's X. X is less than, or it could be equal to 2. Because, in fact, maybe I should write it up here at the very top. So like X is less than, or it could also be equal to 2. So what are valid solutions to this inequality? Well, 1 or 1.5 or -1 or naught, all of these ones to the left of 2 or including 2 are valid options for this inequality to make it true. Let's do another one like this. Visually represent the following inequality on a number line. Choose the one that you think fits these patterns here. Okay, so everyone is saying, so if I let me look at it closer. X is in the middle, it's greater than 1, but it's less than or equal to. So I'm going to have a colored in and not colored in part. So I know straight away that it couldn't be either of these. But it should include the 4 and exclude the 1. So it feels to me like this is the correct one. This is the wrong way around. So I should get D. Yeah, okay. So we're doing nicely here. I like what I'm seeing in the chat. It's lots of D's. Okay, let's do this one. Which of the following words best describes 6p less than 12? So this is just a vocabulary type section. So this is not an equation, because an equation would be something like that. 6p equals 12. Yes. So this is in fact called an inequality, because 6p is not equal to 12. An equality would be an equation. 6p is less than 12. Now, before we take our break, I just want to show you what it means to solve an inequality. You are looking for the values of p that make the statement true. Now, that sounds like a mouthful, but really all you do is you follow most of the rules for equations. And there's a couple of things that are different, but for the most part, you follow the rule for equations. And normally, when you solve an equation, you try to isolate the 6. So you isolate the p. In order to isolate the p or get it by itself, all I need to do here is divide both sides by 6. If I do that, I'm then going to get p is less than 12 over 6, or p is less than 2. So the answer to this inequality is p is less than 2. So what are some answers? Well, an answer that I could get could be 1. So let's see if 6 times 1 is 6 less than 12. True or false? 6 is indeed less than 12. What about a half? If p was a half, is that a valid solution? Well, a half is less than 2. Let's check. 6 times a half is 3. Is 3 less than 12? Yeah. So all of these, there are many different answers to this inequality. So what we do is, instead of trying to list every single one, all I'm going to do, we draw a number line and we put the value on there that's important. So it's 2. And we know that it's all the values of p that are less than 2. And so we illustrate our answer like that. And that's called illustrating your answer on the number line. Now, there's been a very good comment in the chat about switching signs. If you divide by a regular positive integer, you do not switch anything around. So in this situation, I didn't switch anything around. But if you divide by a negative, then you do need to switch the inequality sign around. So let me show you an example of this. Let's start by doing the following. Are you happy? Tell me in the chat. Let's just answer this question. Is -1 less than 3? True or false? Is -1 less than 3? True or false? Okay. Everyone's happy. No bad games, no bad things happening here. Now what I'm going to do is I'm going to divide both sides by -1. Now, there's nothing wrong with that in equation land, but in inequality land, it can cause some strange things to happen. -1 divided by -1 is 1, and 3 divided by -1 is -3. Now, I want you to tell me, is 1 less than -3? True or false? Is 1 less than -3? Now, remember, above, you guys were all happy that above it was true. But in this situation, is this true or false? It's false. So how can that be? How can that be happening? Because you started by dividing both sides by a negative, and you did the same thing to both sides. And this is where inequalities are tricky. If you divide by a negative or multiply by a negative, you have to take the inequality sign and switch it to the other direction. Basically, the crocodile mouth switches the other direction. Now, I'm going to ask you this question again. Is 1 greater than -3? Now that I switched the inequality sign around. What do you guys think? Yes, 1 is in fact greater than -3. So we will practice this a bit in the second part of the lesson, but basically with inequalities, you treat them like equations, except that if you divide by a negative or you multiply by a negative, you have to switch the sign around. You also may not divide by a variable in the inequality. Now, why do you think you're not allowed to divide by a variable in the inequality? Who has an idea about why that might be the case? Just think about it logically. Why would you not be allowed to divide or multiply by a variable in the inequality? I'll give you the answer now, but I just want you to think, why would that be a problem? This is like a higher order. So, losing one of the solutions, yes, that's possible. That's one reason. The other thing is that you don't know for a variable if it's positive or negative. Yeah, so Shantae said it's unknown. Now, if the variable is a negative, you have to switch the inequality. If it's positive, you don't switch it. But you don't know which one of those it is. And so because you don't know, we just avoid dividing or multiplying by a variable because we just don't know how we should treat it. So we just avoid it altogether. Okay, and that's the only difference that we have, basically. It's the negative thing and the fact that variables get handled differently. And also, our solutions are normally shown on a number line. That's the other bit. Okay, everyone, we've done really well. I want everyone now to stand up. And I want you to, I hope you can see me. It's getting quite dark in here, thanks to Eskom, but hopefully my awesome webcam will help me do the job. And you know what's coming, so please stand on up, turn on your webcams. Oh, and what we're going to do is we're going to start this. We're going to start by just taking 5 deep breaths. So that's 3. Yeah, that's 5 breaths. And I want you then just to shake your arms up a little bit. And then we are going to rotate a little bit, slowly initially. And as you feel your body relaxing, you should be able to turn a little bit further around. And it's quite noticeable how tight you are at the beginning compared to where you get to the end. All right, let's roll our shoulders. So 5 rolls back. 1, 2, 3, 4, 5, and 5 forward. 1, 2, 3, 4, 5. And then what I want us to do is I want you to go and grab a pen. So go and grab a pen or marker if you have one, something which you can hold in your hand. And what we're going to do is a little coordination exercise called pen flipping. So you hold the pen on the one end, and the idea is that you throw it into the air and it only spins one rotation, and then you catch it the same end. So watch how I do this. So I go like this. Oh, that was too many spins. So too many. There, that was one. Didn't quite get it right. So the idea is that, can you do it? Can you throw it so that it only spins once? I'm finding it hard in the dark. Let's see if anyone can do it. And if you see it, then you can shout them out. It's much harder in the dark. There we go. I got it. Woo! There we go.
I think Olwethu got it. Democha got it.
It forces your brain to really focus.
Shante.
Oh, it's called pen flipping. You can tell your teachers in class that your extra maths teacher said when you need a break, you can do pen flipping.
Tsukisa almost dropped it.
I'm getting better. The more I do it, the skills are coming back. Oh, too many.
Kinda dropped it.
It's such a good exercise to force your brain to focus because it's so easy to make it spin a lot of times.
Funny.
All right, you're having too much fun. So what I'm doing now is we are going to go from our little brain exercise to a heart rate inducing. We're just going to do 10 jumping jacks so that we get our heart rate up and our blood pumping. So we're going to go in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Give me 5 more. 1, 2, 3, 4, 5. And let me know in the chat if I got your heart rate up or not. Or you like, I am not moved by this jumping jack. I eat that for breakfast. Let me know in the chat if I successfully got your heart rate up there. Okay. So what I want to do now is I want us to move to solving inequalities. So kind of like equations, but a little bit different. So I'm going to do an example, and then you guys can do it after me. So if I say solve the inequality, what are the steps? Well, initially, I add 1 to both sides. So I'm going to get that. Then I'm going to divide both sides by 2, and I'm going to get that. So, there was no moving or switching around because I divided by 2. Now, this has actually got infinitely many answers, right? So x could be 4.5, 4 1/3, -1, 0, -10. Anything which is less than 5 is an answer to this inequality that will make it true. Now, to save ourselves some time, all we do is we illustrate this on a number line. So I go to the point 5, and now I go, x is all the values that are less than 5, but it can't be 5. So I make an open dot, and it looks like that. And that would be 3 marks in the bag for your inequality question. Pat, sorry, we didn't have time because the pen flipping took a bit longer. I thought, but I'll bring Math 24 back again. Okay, so there's been a request to explain the different steps here. So if I say solve the inequality, what do I mean? I'm basically trying to solve it like I would solve an equation, except if it was an equation, it would look like this, and it would have one answer. If it was an equation, if I added 1 to both sides, the final answer would be x is 5. But we're not doing equations, we're doing inequalities. And inequalities are done in a very similar way, except the answer isn't 5. The answer is all numbers that are less than 5. And the way we show that is on a number line. Okay. So I'll do another example for you. So let's say solve the inequality 3x minus 8 is greater than 16. I'm going to add 8 to both sides. And if I do that, I'm going to get 24. And then if I divide both sides by 3, I should get x is greater than 8. Now, how would I show that answer on a number line? Well, I need the 8, and it's going to be all values that are greater than 8. And so it looks like that. Yes, so we did, Fatejo, we divided both sides by 2 the same way we would divide both sides by 2 in an equation. Yeah. Okay, give me a thumbs up if you've understood the basic idea there. Give me a thumbs down if you feel a bit confused. Just want to do a quick little check-in. Okay, then let's have you guys do some of these. Can you do this one for me? Solve 3x plus 4 is less than or equal to 13. Go ahead and do that. And you can pop your answer in the chat when you feel like you have it. Let me go hunting for a light while I use, let's have a look. Oh, I have a light. Let me plug this. Where else can I plug this here? The space on that one. Sorry, guys. So with this one, if I take away 4 from both sides, I'm going to get 9. If I divide both sides by 3, so I get x is less than or equal to 3. And if I'm drawing a representation, I'm now going to have a solid dot, and then I'm going to be going in that direction. So my possible answers, I mean, there could be anything which is from 3, so 3 is an answer, and anything to the left of 3, so will be an answer. Okay. Let us, that was really good, guys. Let's do another one. Let's do one that's a bit more tricky, though. Let me do that one. So I want you to solve that inequality for me. Michelle, I'll show you now how I'd mark them. I'll put the mark allocation in for you, if that is helpful. Initially, students, this is called a linear inequality because the variable only has a power of 1. So linear inequalities are a lot like linear equations. So if there is an equal sign, must we include the number? Yes, Nozi, that's exactly what you need to do. So from the class, I'm curious to know, how do you, what number, or what's your first step in solving this inequality? Who would like to give a suggestion about your first step here? Yeah, I think just clear the brackets. Exactly. So you get 6x minus 10, or distribute the 2 into causal, or Leipy, that's exactly that. And Paul, agreed. So I think you get that. And then you get that. So I got the minus 10 by multiplying out. I got the 6x by multiplying out. And then this one over here has stayed exactly the same the whole way through. Then what did I do? I added 10 to both sides. And that's why all of a sudden I have a 53. That's where the 53 came from. Okay. Now I have the 6 over here. So what I did was I divided this side by 6. Sorry, this is too big. I divided this side by 6 and divided that side by 6. And so x is greater than or equal to 53 over 6. If you want, you could also use a decimal. And so on the number line, I'm going to use 53 over 6. It's greater than or equal to. So it's a solid dot. And then it goes like that. Yeah, you can, Elisa, you can leave it as 53 over 6. There's nothing wrong with that. In some ways, it's more accurate than 8.83 because 8.83 has been rounded. If the question says leave it this way, do it. But that's all we have to do, really. It's still okay if we round, as long as they're looking to see, okay, here's the mark allocation. People are asking about the mark allocation. So I would say that normally I would give a mark for this. I would then give a mark probably over here. Then I would give a mark over here. So that's about 3 marks. Okay, let's do a different type of question now. Just let's do a quick little, actually, before I move on, thumbs up, thumb down vote. Thumbs up, life is good. Thumbs down, feeling a bit lost. There was a question there from a student who said, I divided by 2 at the beginning and I still got the same answer. Completely fine. Completely fine, because you just divided the 2 at the beginning, but it's perfectly fine. So that's another way of doing it. Okay, it's I want you. Okay, here's a little bit different type of question. It says here, n is an integer. So integers are the numbers without fractional bits. N is between -2 or greater than -2, but less than or equal to 3. List the possible values of n. So what possible values of n are there that obey this inequality? I want you guys and girls to try and write that down for me. So one of the answers, Kat, is -1. You're absolutely right. I agree with you. What are the other answers? So -1 is one of them. And then we have a 0, and then a 1, and then a 2. And the sneaky one that not everyone will get is the 3, because it said less than or equal to 3. Now, in this situation, we're not including like -1.5, because it's only integers, and -1.5 is not an integer, whereas normally we would. Okay, so that didn't seem too hard for you guys, which is great. Let's go and find something a little bit more exciting for you. Let's go down further. let's do, I want everyone to try and solve that inequality. Can you solve that inequality for me? So for Tekel, all that, the main thing that you are unsure of there is the idea of an integer. So because the question deliberately said integer, we only had numbers between those two values that were integers. And then, yeah. You guys are doing well though. Level, you still see me, or am I just a head floating in the darkness?
We can still see you, Mr. Hughes.
I'm impressed by my webcam then. I'm very impressed because it's,
Yeah, it just looks like a black background.
yeah, well, that's probably what it mostly is. Yeah. Okay, so if this was an equation, normally you would move all the variables to one side. And so my first step would be to do this and then bring the 4 across where it becomes -4 minus 14. So that would be step 1, like an equation. Notice that you didn't divide and you didn't multiply. So there's no switching whatsoever. Then I would say this is 4x and this is minus 18. So I'm going to divide by 4 on both sides. And I get x is less than. Now, I guess you could write -4 and 2/4 or -4.5. And so the answer, you would definitely need to have a -4.5. And its x is less than that, but it's not including -4.5. So it would just look like that. And that is slightly harder inequality. Are there any questions or comments? It's completely fine to say -9/2. That is equivalent to -4.5. Okay. So the first step, so what I did was for Tekel is when I moved this across, or I took away -5x from both sides. And then this part over here, when it went across from plus, it became a minus, which is here. So all I did was this, if it was an equation, you would try and move the 5x to the side, in which case it becomes -5x. And then with this one, when it comes across, it becomes -4. You could say for Tekel, as long as you got -18, yes. Yeah, no, I'll come back to the one with the list values. I'll come back to that at the end. Okay, I will have another look at that. Well, let's do another one like this. We can do it together. Kat, it is, but then you need to make sure when you finish the question, I can't say completely. You can think of it as an equation in your head, but you should still be writing inequalities as you go. All right, let's try and do this together. N is an integer. Now, normally, if they don't say this, N would just be a real number. Okay, so this is something special. It's limiting N's, like what N can be. N is greater than or equal to -4 and less than 1. I want you to try and write down all the possible values of N. Yazi's question. So we won't be penalized whether we write as a decimal or fraction. You won't, Yazi, unless there's some particular instruction which is do it that way. But also rounding marks are capped. Your teacher can't take off more than 1 mark per test paper for rounding. And the same at the end of matric. You can only lose as far, like you. So don't stress too much about. Do the best you can. Finance is a bit different. but general rounding error is a capped mark. You can only lose so much, you can't lose 10 marks for rounding. That would be unfair. Okay, so what do we have here? The -4 is the first one, then -3, -2, -1, 0. Now, why is 1 not included? Who would like to come online quickly and explain why 1 is not included here? Because some of you have included 1. Now, I'd love to hear from someone in the class if anybody's willing to share their thinking. How did you know you didn't include 1? Okay, so Andile has said it's because it's excluded. N is less than 1. So yes, so if you look at the beginning, N is strictly less than 1. And so you can't have 1 appearing on the list where it says N is less than 1. It would be like it has a problem recognizing its own existence. So I hope, does that help a little bit for those students who are struggling with this type of question? Does that make it a bit easier now to understand kind of what's going on? Nozi, you're quite right. It doesn't have an equal sign. Fantastic, Ayanda. I'm very glad. I want to find one that challenges you guys. We're running. Okay, that maybe we don't have time for that. Let's have a go at this one. Actually, you know what? We'll start the next lesson. It's fine. We've done enough for today. In the next lesson, we will start with this type of question, and we will also talk about quadratic inequalities. But for today, we've actually done enough. So Level, if you could please put the link to the quiz, the poll. And Elisa, we do past papers. We do exam workshops in May. We're going to do exam workshops. Although a lot of questions here are from sort of past papers as well, but we do specific exam prep in May. So just watch out for those workshops. Okay. Somantei, if the question wasn't an integer, then you would have to just draw a number line like we were doing earlier. So these questions where it says x is an integer, that's the exception. That's the one that they don't often ask. If they said to you, solve the question or when x is between -3 and 4, then you know that is the answer already. And if you drew it on a number line, it would just look like this. That's if it wasn't an integer, right? So it's all the numbers that come between -3 and 4. So like -1.5 and whatever. But in this question, sometimes they say it's only the integers, and then you can only get -2, -1, 0, 1, 2, and 3. Okay. Awesome, everyone. It was lovely teaching you today.